we've simplified radicals. We were pros at this. We were looking for perfect squares that make up the numbers we see here. So 52, we're thinking, oh, well, that's 4 times 13. So we put it into 2 radicals, root 4 times root 13. And then we took the square root of 4, which is 2 root 13. No more perfect squares than 13, so we were done. 200, we're like, oh my gosh, that's 100 times 2. The square root of 100 was 10 root 2. And we're like, 4 root 54, get out of here with that noise. I know that 9 goes into 54. 4 times the square root of 9 is 3. 4 times 3 root 6 is 12 root 6. And last one, 125x squared. Now, if I'm just looking at 125, I know that's 25 times 5. And with variables, the even exponents are perfect. So we'll put x squared all over there. Square root of 25x squared is 5x. And then you got your leftover root 5. So just like when you were doing back in the day, 2x plus 7 plus 8x, the only ones you could combine together are 2x and 8x. That would give you 10x plus 7. Those are like terms. With radicals, you can only add or subtract them if they have the exact same number in the radical. If they don't, you can't combine them. However, you got to make sure that you take out all the perfect squares before you determine that. So if you look here, we have root 2 plus 3 root 2. They're both root 2's. Now, what number's outside of this first root 2? That's 1 root 2 plus 3 root 2. Now think in your head, if you hear that, you have 1 root 2 plus 3 more root 2's, that's 4 root 2's. You don't change the radical when you add or subtract. Only if you multiply or divide do you change the number in the radical. So all we have to do is the outside stuff. 1 plus 3 is 4. That's 4 root 2's. Unbelievable. If you look here, these are both root 5's. So we're doing negative 3 minus 4. That would be negative 7 root 5. And over here, they're both root 10. So we have 1 root 10 minus 5 root 10. 1 minus 5 is negative 4. Then you got the root 10. And you're like, Mr. Plant, what if they don't have that same radical, though? I'm so glad you asked. So glad. Like these. 7 root 3 minus 12. Boom. They don't have any... they don't have the same number, so we're all done. We can't combine them. Unless... any perfect squares in 12? Yeah. Oh, goodness. 12 is the square root of 4 times the square root of 3. And the square root of 4 is 2. So now it's become 7 root 3 minus 2 root 3. Oh, now they're both root 3's. So 7 minus 2 is 5 root 3. So you got to take down all the perfect squares first. And then you might be able to add them or subtract them. You might not, and that's okay. Let's say you work it all the way and you end up with 4 root 2 plus 8 root 3. Different numbers in the radical. You'd be done. You can't combine those anymore. That's it. But you have to get all the perfect squares out first. So 3 root 20 plus 2 root 5. I know that 20 still has a 4 in it. So I'm going to make this 3 root 4 root 5. This 2 root 5, there are no perfect squares in 5, so we'll just hold off on that. The square root of 4 is 2, so we have 3 times 2 root 5, which would be 6 root 5. That's all we can do there. Plus 2 root 5. 6 root 5 plus 2 root 5, we're just doing the 6 plus 2, 8 root 5. Let's try it one more. 3 root 3, nothing perfect there. 2 root 27. 27 is 9 times 3. 2 times square root of 9 is 3 root 3, which would be 6 root 3. So we have 3 root 3 minus 6 root 3. 3 minus 6 is negative 3 root 3. That's it. We're done with it. Only add or subtract if it's the same number in the radical.